Okay, so what I was saying is distance must be calculated by theta over 360 degrees times 2 by r. Okay, so I said differences in degrees. So I was saying here when you write everything like this, so you have to consider what is given is in kilometers. So kilometers is given in 6370. 6370. This is in kilometers. Okay. When you punch everything with your calculator, you write distance is equal to, okay, before you punch everything with your calculator, you add this because you're talking about differences in degrees. So you add that, you are going to have 60 over 360, okay, degrees times 2 times 3.142 times 63, 70 like that. When you punch everything with your calculator, okay, here, what you have here, okay, what you have here, you have in kilometers, and this is in most common paper too. So what I'm saying, you punch just everything in your calculator. You have to use your calculator, and when you use your calculator, you are going to remain with something must be okay. Something like 6,000. I'm sure you must remain just in 4 significant figures. Okay, so in kilometers. But when you use your calculator, I'm sure you write something that may be different to that. But I'm sure when you punch everything with your calculator, I'm sure you must remain with that. So we are calculating distance in what is same longitude. So we are calculating A and E. So we are calculating A and E, and this is all we can write for now. Okay, this is all we can write for now. So what I'm saying is, when you're calculating the distance, we follow this formula. Okay, this is the formula we follow when we're calculating the distance. And we say differences in degrees. I have explained this. We say north, we subtract. South, we subtract. But north and south, we add. That is differences in degrees. And you place everything with your calculator. I'm sure you are going to remain with something like that. But if you use your calculator, maybe you can remain with something different to my answer. I'm not using a calculator, I'm just trying to approximate the value where there must be in that way. Okay, so this is how you can calculate in kilometers. We go to distance, we go to this one now, in nautical miles. We go in nautical miles. A and B. So we talk about A and B in nautical miles. Okay, so let me remove this. Okay, so let me remove everything here. Let me remove everything. Please, I want to tell you that, I want to say that when you have challenges, you write a comment on that group. You write a comment, you say you are not clear on this part. Okay, so we are talking about the earth geometry here. Okay, we go to distance between A and B in nautical miles. So we start talking about this distance here, this distance between that. Okay, so what I'm saying is we follow the same formula. Just maintain the same formula. That is distance is equal theta. Now we are saying here, this is where I'm saying theta must be difference in degrees. Now here we have, this is B. B is what? So let me write like this. B is what? 80 degrees north, 80 degrees north. This is latitude, and longitude we have the same, 20 degrees east. Okay, and we are looking for A now. A is what is A here? A is 40 degrees north again. Okay, and we are on the same longitude. Okay, we are in the same longitude. We write like that. Okay, so when we write like that, we have everything like that. We are saying differences in longitude. This is where differences in degrees. This is where now we need to have north and north because we have the same east there, degrees in east. Okay, so here we subtract because we have that and that. And when we subtract, I'm sure you're going to remain with the, okay, so distance is equal to 80 minus 40. Okay, 80 minus 40 degrees, 360. There I added, but here I've subtracted. Reason, we have the same poles. We have the same poles, north poles. Okay, so I'll write 2 times what is my pi? My pi is 3.142 times. Now here we are dealing with the values in nautical miles, the distance in nautical miles, which is given by 34, 37. Okay, it is given 34, 37. That is the radius we are talking about. Okay, so when you write that, then this is where I'm saying you place everything with your calculator. Here you are going to remain with the 40 over 360 degrees, here 360 degrees times 2 times 3.142 times 3437. This represents the radius in nautical miles. That is the radius in nautical miles. This one is the radius in nautical miles. Okay, so here you punch again everything with your calculator. You punch everything with your calculator. I'm sure when you punch everything with your calculator here, you are going to remain with the something like 1,900. Okay, something like that. Just punch that with your calculator, please. I'm sure we are all on the group. We are all on that group. So what I'm saying is, what I'm trying to encourage here is, if you are not clear, on any of these two questions, please you can ask. And I'm sure next time you will come to how to calculate time. Now there is the point I want to make. When you're calculating the distance, we deal with latitudes. And what you have to know is that there is what we call the equator. This line must lie on the middle of the earth. It is called the equator. This line is called the equator, this line. But it has to be somewhere like here. Now, don't worry, when it's at 0, just know that it's the equator. Again, here, we have the line that is called, we have this line. This line is called a Greenwich meridian, GMT time. We use this one to describe what we call green meridian time. Okay, green meridian time. So this line catches the earth or divides the earth on 2. Okay, so that is the green meridian time. Okay, so here we use, when we start talking about time, the differences in time. But today we are just talking about how to find the points, how to write the coordinates of the points on the earth's surface. Apart from that, how to calculate the distances. Okay, so that is the formula when we are calculating the distances. Apart from that, let me emphasize you. Apart from that, we have the circumference of the circle. The circumference of the circle. And I'm sure the circumference of the circle is written by, 2 pi r. Okay, this is the circumference of the circle. And when we're talking about the circumference, we know what we're talking about. We're talking about all the total surface area of the earth. Okay, so the circumference of the circle is given by that. Now, I said that we have a great circle, a great circle. A great circle that is given by the what? That is given by the longitude. The great circle that is given by the longitude is calculated by that. And we have the small circles that can be calculated by latitudes. Okay, so the small circles is calculated by the circumference 2 pi. This is pi. R, small letter r. This one must be capital letter r. This is how we calculate the circumference of the circle. We have to be provided with that formula. Okay. Okay, you have to be provided with that formula. So today we are just answering distance along a circle of longitude. They are called great circles. So we are talking about distance along the longitude. Distance along the longitude, we are answering the distance of great circles. Next time we'll start talking about finding time. Okay, finding the differences in time. That will be the next time. Okay, so what I want to tell you is I'll send you some points to remember on that group. When I send some points to remember, please follow those points when calculating distance, points, when locating points, calculating distances, time, and speed. So we'll come to that in the next topic, but please, I'll make sure that we'll conclude this topic within next 3 days, okay, or next 2 days. I'm sure next 2 days we'll conclude, because I'm sure you understand something when you're calculating the distance. Okay, so next time we'll go to calculating time. I'm sure this is loud and clear for everyone. So please make questions. Try to go through papers. You go through paper 2, you go through paper 1, and make questions. Okay, so